guys, welcome back to the channel. My name is Jag, and in today's class we are going to continue with our grade 10 math content, and today's topic is going to be quadratic relations. And again, the quadratics unit is the most important unit in grade 10 math. Okay, so with that, let's get started. What we're going to look at today is the finite differences. Okay, let's try this example. I wrote it on the board. It says y equals 2x minus 5. All right. It says, how can you use finite differences to determine if a relation is linear or quadratic? Okay, and sometimes the teacher will just give you this. Okay, it's just going to be like an equation. Okay, what I want to do, okay, is I want to make my x and y table. And again, I can pick any values for x that I want. Okay, what you should always be choosing is the -2. Okay, all the way to +2. Okay. And what I'm going to do is I'm going to take my x values and I'm going to plug it into my relation here. Okay, so let's start with x equals -2. So I'm just going to show you how to do this. Okay, so I'm going to plug it into my equation. So I'm going to rewrite the equation here. Okay, and instead of the x, I'm going to put -2. Okay, so it's 2 times -2 minus 5. All right, so I can see it's -4 minus 5, which is equal to -9. Okay, after you get your answer, you're just going to plug in your answer right here. So it's -9. Okay, then I'm going to move on to the next value of x. Okay, so here we are trying -1. So I'm going to do 2 times -1 minus 5. Okay, and as you go down the table, you'll notice that there is basically a pattern. Okay, so I'm going to put, this is -7. And again, if you're not sure, just take your calculator and you can plug it into your calculator. So I'm going to put -7. Okay, and you keep doing that, okay, until you get to +2. So this is a good range, okay, of the x values. Okay, I'm just going from -2 to +2. The next one is 0, so I'm going to plug in 0 here. Okay, into my equation, and it's just going to be 2, let's write it here, times 0 minus 5, okay, which is equal to -5. Okay, and I can see that the number is changing by +2 each time. Okay, that you can just add +2 here. Okay, so the next one is going to be x equals 1. I'm doing 2 times 1, okay, which is 2. 2 minus 5, so -3. Okay, so even if you want, you could just use your calculator for this. Okay, the teacher isn't going to ask you to show your work in filling out the x and y table, because that is something that you did also in grade 9. Okay, and the last one is x equals 2, so I'm going to plug that into the equation. So 2 times 2, so 4, and 4 minus 5, okay, which is -1. All right. So I can see, I'm going to take out this because this was just our work on the side. Okay, so I have my x and y table. I have to use finite differences. So the first thing I'm going to do is I'm just going to extend this and I'm going to write FD. So this is the first difference. So this is just like what you did in grade 9. Okay, I'm going to start from the bottom going up. Okay, and this is going to be, I'm going to subtract it. So -1 minus -3. Okay, and again, make sure you're watching the signs. This is -1 plus 3, so +2. And I'm going to go to the next numbers, okay, or next set of numbers. So -3 minus -5. This is -3 plus 5, okay, so +2. Okay, and you keep doing that. Make sure you're always starting from the bottom going up, okay? That's really important. So -5 minus -7. So again, this is -5 plus 7. So this is +2. And I can see a pattern. My first differences look like they're all the same here. The last one is -7 minus -9. Again, this is -7 plus 9. So it's going to be +2. Okay? So now you can see basically all the first differences are the same here. Okay? And that makes this relation linear. Okay, so let's write it on this side. So therefore, this relation is linear. Okay, so this is kind of like a review from grade 9. Okay, I was using the first differences. Okay, to see whether or not my relation is linear or it's non-linear, okay? What you're going to do at the grade 10 level is I want to see if the actual relation is a quadratic, okay? This is what a quadratic relation looks like. It's basically just a curve like this, okay? Either it's opening upwards or it can also be opening this way, opening downwards, all right? So with that, let's try an example. So let me just take this off. Okay, let's go to the next example in the textbook here, okay? So it is y equals x squared minus 4, okay? So again, let's do the x and y table. Okay, and again, I'm going to take the same values for x, okay? So we're going to do -2 to +2, okay? Now this time when you're plugging in your value for x, make sure you are doing the exponents, okay? So I'm just rewriting the equation. It's y equals x squared minus 4. So the first value I want to plug in here is -2, okay? So I'm going to do -2 squared minus 4, okay? So remember again, this is -2 squared, so -2 times -2, +4. So this is 4 minus 4, okay, which is equal to 0. Alright, just like that, and then I'm going to plug in my -1. So I'll do -1 squared minus 4, okay? And this is going to become +1, so it's going to be 1 minus 4, and that's equal to -3. And you can see I'm just basically plugging in the values. I want to know all the y values, okay, within my table. When you plug in 0 here, the whole x value is just 0, so I'm left with -4. Okay, and you'll notice whether or not you plug in -1 or +1, the answer is the same, and that's the reason for that is the x is whole squared here, okay? So it's going to be -3. Same thing for -2 and +2, okay? I'm going to get the same answer here, okay, which is equal to 0. All right, and that's again, it's whole squared minus 4. So it's just 4 minus 4, which is 0, okay? So I'm going to take this off. And again, we have to use the finite differences, okay, to see whether or not this relation is a quadratic relation. So first off, I'm going to extend my table like this, okay? We're first going to try the first difference, okay? So start from the bottom up, so 0 minus -3. So again, this is just like 0 plus 3, so it's 3, okay? Go to the next two numbers, okay? So I'm doing -3 minus -4. So this is -3 plus 4, so +1, okay? And then I'm doing -4 minus -3, okay? Again, make sure you're watching the signs or just use your calculator and you could just punch it into your calculator, okay? So -4 plus 3, this is -1, okay? And the last one here is -3 minus 0, okay, which is also equal to -3. So now I notice that all my first differences are different, okay? What I'm going to do next is extend my table here. This is the second difference, okay? And the second differences will tell you whether or not this relation is quadratic. Now you notice all the first differences are different. So I know that it is not linear, okay? Can we see that? So let's put not linear. And that's the only time I'm going to move to the second difference. Again, I'm going to start with these numbers here. Start from the bottom going up, okay? So you're doing 3 minus 1, which is equal to 2. And I have to make sure I watch the signs here, okay? And for this one, it's 1 minus -1, which is actually 1 plus 1, so this is 2. Okay, and this last one, I'm going to do -1 minus -3, okay? So again, this is -1 plus 3, okay? So this is +2. Okay, so what you notice here is all of the second differences are the same, okay? And when you see this, this is basically telling you that this is a quadratic relation, okay? So I'm going to put therefore, this is a quadratic, okay? So I basically know it is a parabola. okay, it's either opening upwards or downwards, okay? If you look at the second differences, okay, the second differences are positive here. It's plus 2. So I actually know that this relation is opening upwards like this, okay? And that is one way to kind of like do a mental check, and you can check your answer, okay? So let's just sum up what we did here. I was given the actual equation, okay? I took this equation, I made my x and y table, all right? The values for x I took were -2 to +2. I plugged in the values for x, okay, into the relation to get my y values, okay? Then I did the first differences, and the first difference was just to show whether or not it is a linear relation. If it's not linear, I'll see that all the first differences are different, okay? I will move on and extend my table to make a second difference chart, okay? And I'm going to take my first differences, subtract them again. And if I notice basically that all the second differences are the same, okay, that means that this is a quadratic relation, all right? Now your question is probably, Jag, what if the second differences are not the same, okay? In this case, I know that my relation is not a linear function and it's not a parabola, okay? Which means it's basically neither, okay? And that's all you need to put, okay? And it's going to be like maybe a curve. It's just not going to be like a parabola like this, okay? But there are many different types of curves. That's not going to be for the grade 10 content. You're going to go through that in grade 11 math, all right? So if there are no questions, that brings this video to an end. Again, we covered quadratic relations using finite differences to determine whether or not a relation is linear or quadratic. If you like the content, please make sure you're subscribing to the channel and click on the like button below. And I will see everyone in the next video. Thanks, bye.